So we're going to talk about these two new formulas, the law of cosines and the law of sines. And we're going to do this in the context of solving triangles, taking triangles that we have partial information about and finding all of the missing information, all of the other dimensions. And there's four cases that we're going to be able to solve here, right? And you notice how I've described these using kind of the language of geometry. Angle, side, side, side. These are all based on what information I know, right? So the law of cosines, that's going to help us with the last two, with 3 and 4. If I know all three sides of a triangle, the law of cosines will help me fill in the angles. And if I know a side, an angle, and a side, I want to be clear about what we're talking about now, right? That's a side, and the angle in between them. Then I can find the length of this missing side and the other two angles. All right, so let's see how we're going to do that. Well, first, the formula, right? This is it. C squared equals A squared plus B squared minus 2AB times the cosine of C. Well, that's the law of cosines. And you notice it's playing off of this, kind of off of the same language as the Pythagorean theorem. If I have a triangle, you notice it's not necessarily a right triangle. This formula works for any triangle. Then if I have C, A, and B, and this is C, right? Again, we're using that same notation. Angle C is opposite side C. Then that's what the formula tells me, right? The formula gives me a relationship between those four measurements. All right, so let's see how we can use this, right? I have this situation, right? I know two sides and the included angle, right? So what I have here looks like this. I have side A, that's 4, and I have side B, ooh, that's a mess. Sorry, let me try that again. And I have side B, that's 5, and I know this angle here in the middle is 35. Okay, so first, let's just go straight to the formula, right? Let's use this to find side C. Well, that's just dropping my numbers in. C squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 35 degrees. All right, so let's see. Now we're going to go to our calculator a lot with these. This tells me that C squared is 8.233, and if I take the square root of both sides, C is 2.87. Okay, excellent. Now what? Now I need to find the missing angle, right? I got to fill in angle A and angle B. Well, I can use the law of cosines to do that as well. And here, remember, which angle gets to be A and who gets to be B and so forth. The labels don't really matter. What the law of cosines is saying is the opposite side squared equals the two adjacent sides squared minus this expression with the angle. So look, I'm going to try to find angle B. All right, so what this formula says is 4 squared, that's the side opposite the angle I'm looking for, is equal to 2.87 squared plus 5 squared minus 2 times 2.87 times 5 times the cosine of angle B. Right? Now we go to our calculator. Let's see, I get 16 equals 33 0.2369 minus 28.7 cosine B. All right, so now let's move things around. Move the 33.269 to the other side. Negative 17.2369 equals negative 28.7 cosine of B. Divide both sides by 28.7, and we get cosine B equals negative 0.6006. Take the inverse cosine of both sides. Right? We get B equals 87.799. Okay, so that's my third angle, second angle, 87.799. And look, keep it simple to find the third angle, right? Don't do the fancy trig and formulas and all of this. The measure of angle A is 180 degrees minus 35 degrees minus 87.799, which comes out to, let's see, 180 minus 35 minus 87.799. I got my calculator going here. This is 57.201 degrees. And that's it. Right now I filled in all the pieces. I know A, B, and C here. So what did I find? If I just to summarize this, C is 2.87. The measure of angle A is 57.201 degrees, and the measure of angle B is 87.799 degrees. Okay, so how about this one? Side, 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 right? I know all three sides here. And this time, what I need to do is find all three of the angles. Well, again, my formula works just fine. I'm going to try to find angle C. So I'm going to put the numbers in just like they appear here. 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of C. So let's see, that's 100 equals 25, and 49, that's 74, minus 70 cosine C. Move the 74 over, 26 equals negative 70 cosine C. Cosine C equals negative 26 over 70. Take the inverse cosine of both sides. C equals 111.804 degrees. Right? There's my first angle. Okay, so how do I find the second angle? Well, pick one first. Pick one to try to find. I'm going to go for angle A, right? Which means I need the cosine of A in my formula, right? Which means A squared has to be over here on the other side, right? Because the angle and the side are kind of on opposite sides of the equation. So what's left? That means that this must be B squared plus C squared minus 2BC. Okay, now again, let's put our numbers in. 5 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of A. All right, so let's see. This is 25 equals 149 minus 140 cosine of A. Subtract that 149 from both sides. Negative 124 equals negative 140 cosine of A, divide by 140. Cosine A equals negative 124 over negative 140. Inverse cosine of both sides, and we get A equals 27.660. Okay, and that's it. One left, right? But B, remember, we always get the last angle the easy way. 180 minus 111.804 minus 27.660. This comes out to 40.536 degrees. There you go. Now we have all three of the missing angles. Okay, so how about this one? This one, I'm not just throwing another one out here for the sake of throwing it out here. This one actually is going to be special. Let's try this out. I'm going to try to find angle C. So we're going to have h squared equals 2 squared plus 3 squared minus 2 times 3 times the cosine of C. So what do we get? This is 64 equals 4 plus 9, that's 13, minus 12 cosine of C. Subtract 13, 51 equals negative 12 cosine of C, and then divide by negative 12. Cosine C equals negative 4.25. And here we got to stop. You can go ahead and ask your calculator. You can try to do that inverse cosine if you like, but your calculator is going to get very upset with you. The cosine of an angle can't be negative 4.25, right? Cosines have to be greater than negative 1. Right, so what happened here? Well, not all combination of lengths form a triangle. And this is how you can tell that you've come across a bad set of numbers, right? If you get something like this where you can't find that inverse cosine, then there is no solution. This triangle doesn't exist, right? And to see why, let's try sketching this out. I'm going to try and do this to scale. So if this is 8, then the other side here is 2, and this side here is 3. You see the problem, right? If I start to kind of tilt these in towards each other, trying to get them to touch and make a triangle, they never do. They make it all the way down here and all the way down here. This is 2, this is 3, and there's still this gap in the middle. Right, so yeah, these three side lengths don't make a triangle, and this is how you can tell when we're using the law of cosines. Okay, so that's law of cosines. Right now we have one more, right? One more to think about. That's going to be the law of what's called the law of sines.